Hello, my name is Gabriel Torquato and welcome to my Lab 4 video. So previously in Lab 3, we created a brainless microprocessor. So basically we had to manually input things in the digital in order for it to do stuff like add, invert, subtract, store values in the RAM. So in Lab 4, we had created a microprocessor with the brain, essentially. So now our microprocessor has a controller, which does exactly what it sounds like. It controls our brainless. And we also have an address generator because that just helps us cycle through addresses. So I'll just give you the rundown. So here's our microprocessor V. These are instructions. So think of these as like a set of instructions that our microprocessor can always look at. These are also the same instructions, but the difference is that these instructions can be read in the digital. These instructions are read for the JTK waves. Same thing here. These instructions are for the digital. These ones are for the wave. So essentially, what our random access memory does, the it tells the computer, it tells basically the microprocessor, okay, I need you to look at this set of instructions. I need you to do them in this order. So basically it's basically a computer. So then the microprocessor will go, okay, I'm gonna look at this, and based off of those instructions that you gave me, I'm gonna do this, this, and this, right? So I'll give you a little example here. So in this microprocessor, I'm going to give you the example of the very last one, which we store a value in a random access memory. So we'll go and go. Everything's loaded in. So in our controller, it holds all of our instructions and opcodes. So that's where it pulls all that stuff from, which is in here. So when we first click, I'll go and pull this up again. When we first click, I'm telling this processor to pull up the set of instructions at 6. So this is performed in opcodes. And if you don't know what an opcode is, it's basically a set of 4 instructions. So we're at instruction number 6, instruction 6 with the 4 instructions. So here, the first thing it does, it's basically telling you to read instruction 6. So once we click, that's what that 20205 is right there. Right there, load instruction set sub. So click again. So now we're at 234. So now 234 is telling to load the value into the accumulator. Now we're going to zoom out. And the value is not in the accumulator yet. We have that F and the ALU out. I put that ALU out there so it's a little easier to understand what's going on and what all the values are in the wires. So now if we click again, oops, wrong one. Our value is now in the accumulator. So that's exactly what we wanted. But now we are on instruction A. So technically it's 00A, but the zeros don't put. And the 3 is our address generator. That is telling us the address. So that's why you don't see that 3. It's just being stored in here. So now here we want to write whatever value we have in our accumulator into the address that we have counted up to in our RAM. So that's exactly what it's doing right here, F accumulate. So if we click one more time, that should have now written it into our accumulator. So now we're at instruction 202, which right here tells us read the value from inside the RAM. So the only way to prove that we have loaded that value into our RAM is if we read it straight from the RAM. So now we're at, right here you can see address number 2, which is where we saved it. So we're going to read whatever is at address number 2. So if we click again, the F is still in the accumulator, which is exactly what we wanted. So now we are back here. We're back at the very top. Because it's a 4 set of codes, we were just going through it because we set this hex digit right here. It just tells us the next step that we want to go to. So now we're at the very top. As you can see here, that's the F that we want to read in, and this is just placeholder to make sure everything just flows right. And here is 2. So since we are now done and we are setting this right here, the load IR, because now we want to load an instruction register. So basically a set in the opcode. We're now going to load in 2. So our 2 is basically stop. So we want it to stop. So now if we click one more time, 205, we're going to click it one more time. We should be at a stop, so 0, because our stop is telling us, okay, 1000, you're going to stay here. So that basically worked. We know that the F loaded into the accumulator, was stored in a random access memory spot, and we can see it clearly right there. As well as that, we'll go ahead and look at the JTK value that I have here. This is just another way of viewing it. So you can see here our F comes into play right around 300A, which is when we're storing it. And then right when we want to read it at address 2, it is still F because our read is set to 1. We're reading at address number 2. It's still F. So we can clearly see that F is there. So yeah, this was a pretty interesting and fun lab to do. It's basically like build your own computers, like really microprocessors. So it was really interesting to finally do that. I can only imagine like the amount of other things that you could do if you incorporated like other functions into your brain list. It can get real complicated. And probably the biggest issue I had was just the amount of stuff that you have to keep track of because we have different files, different things looking at different things, different files looking at different files, reading, etc. And especially with counters, when you have counters involved, it's constantly counting, so you may accidentally count a value that you don't want to count, and now you're reading from a different address bus, which is a big issue that I had. I had a lot of things reading from incorrect address buses, different opcodes, and it was just a mess. But we eventually got it figured out. Thank you to the TAs, Allison and Jillian. They were very helpful. But yeah, I hope you guys enjoyed this video and are interested in microprocessors.